Okay, this is a video about horizontal tangents. Okay, it says determine all values of x, so they want all the x guys, if any, at which the point of the function has a horizontal tangent. So the big idea here, okay, what we want to do when someone asks us for a horizontal tangent is that we have to take the derivative of the function and set it equal to 0. And the meaning behind this is that we want to find a tangent line. So a curve has lots of tangent lines. There could be one here, there could be one here, but there's a special one out there that has a slope of 0, and those type of lines are horizontal. So this is when the slope is equal to 0. So all we have to do to find a x value for which the function gives a horizontal tangent, we just have to set the first derivative equal to 0. We want to know where the slope of the tangent line is equal to 0. Okay, so this is a challenging one in terms of taking this derivative. We have to use the quotient rule, and the numbers are going to get pretty large, so we have to be very careful. Using the quotient rule, I take the denominator and I square it, so 2 times 2 is 4, and then I just put the original guy here. And then I take the derivative of the numerator, which is just 2. I'll put a minus sign in, and I'll leave the numerator alone this time. And using the power rule, I'll take the derivative of the denominator, and I'll take a 2, which is the derivative using the power rule of throwing the exponent in front. I'll subtract 1. And if you're thinking that you should use the chain rule, that's fine, because if you did use the chain rule, the derivative of the inside is just 1. But for that reason, we don't really write that. Okay, so let's see if we can clean this up. It's going to be 2 times this binomial squared. So I'll write as x squared minus 20x plus 100 minus, now let's just be careful over here, 4x x minus 10. Alright, lots of steps. I like to write things out. Okay, we'll distribute that 2. We get a 2x squared minus 40x plus 200. Yeah, it's the big guy. Be careful with the negative. I get a minus 4x squared plus a 40x all over x minus 10 to the 4th. I can cancel the 40s out. I'll get rid of those guys. And then, combining like terms, let's see, that's going to be a 2x, a minus 2x squared actually, a minus 2x squared, so this guy's done, plus 200 all over x minus 10 to the 4th. Okay, so you found your first derivative. Now remember what you have to do to find a horizontal tangent at this point. Okay, you have to take it and set it equal to 0. Now, you'll notice I put a 1 underneath. That's just to get everybody used to cross products. So that means I can cross products across equal signs like this. So 1 times negative 2x squared plus 200 is negative 2x squared plus 200. And the neat part about the denominator, it just cancels out, and that turns out to be 0, because anything times 0 is 0. Then I get negative 2x squared is equal to negative 200. I'll get x squared is equal to 100, and then here we can see that x is equal to plus or minus 10. Okay, so which values so far, so be careful, so far, so be careful here, we think the answer is the x values which give horizontal tangents is 10 and negative 10. You could use or here, but it would be inclusive. It would be this or both. Now be careful here, because if you go all the way back to the derivative, you can see where's a good spot, right about here. So let's really focus on this guy right here, right now. Now if you look at the denominator, okay, we have to be very careful here. If you look at the denominator, and anytime I see a denominator, what I like to do is I like to say the denominator, x minus 10 to the 4th, is not allowed to be 0. So if I take the 4th root of both sides and then add 10, x is not allowed to be 10, because that would be where a a vertical asymptote would occur. We learned that in algebra. In other words, you can't divide by 0. If I put a 10 in there, 10 minus 10 is 0, and that won't work. So we have to restrict our answer. So since x is not allowed to be 10, our only answer is x is equal to 10 is the only solution. Only value that gives a horizontal tangent. Okay, I hope that helped.